Let's keep crack-a-lacking here. On to problem number 2 now. Oops. What the heck am I doing? Okay, there you go. All right, so we have our next rational function, x squared minus x minus 2 all over x minus 1. And as always, let's just go ahead and factor the numerator just to see if anything does cross out with the denominator. You just never know. Little tricks in the trade here. Let's just see what happens. So let's see, we factor this. Was that going to be x minus 2 times x plus 1? Let's make sure that's negative 2. Now give us negative 1. Good. All over x minus 1. And it looks like nothing crosses out. So don't be tricked. Don't be like, oh, it's just a little sign. No, we can't do any right there. Okay, so we got to leave that alone. All right, well, let's just go ahead and start now. Our y-intercept, which always means that we let x equal 0. So if I do f of 0, well, look right here, 0, 0, negative 2 on top, 0, and then negative 1 on the bottom. So that means we have a y-intercept of 0, 2. Okay. The x-intercept, that means we only want to set the numerator equal to 0. Well, we already factored it, so I'm just going to set these two guys equal to 0, and then I'm going to be able to solve for x. Okay, so that rule that I'm using is that we only set the numerator. That's it. Not the denominator, just the numerator equal to 0. And so we get to 2 x-intercepts at x equals 2 and x equals negative 1. Okay. Now, what about the VAS, the vertical asymptotes? What value or values make the denominator 0? One value, right? Only 1. So that means x equals 1. Okay, right here, x equals 1 because that's what makes the denominator 0. Horizontal asymptote, let's look at our degrees here. Well, the numerator, the n, is bigger than m. So we have n is bigger than m. And if you recall from your notes and what we learned, that when the numerator, n, is bigger than the denominator, then that means that we have no horizontal asymptote. However, that means we have a slanted asymptote. Okay, so let's go ahead and find that guy. And the way that we do that is we're going to have to use long division. So we're gonna divide x squared. Oops, I should probably give myself a little more room than that. I'm gonna be able to squeeze that in there. So let's see. I'm gonna divide. Let's see, x minus 1 by x squared minus x minus 2. All right, let's make sure I got the signs right there. X squared minus x minus 2, x minus 1. All right. So again, the only thing that we're interested in when we do this is just the quotient. So whatever we get up here, that's all we're going to look at. That's going to give us our horizontal, I'm sorry, our slanted asymptote. Okay. So let's go at it. X goes into x squared, x times, right? Because x times x is x squared. And then x times negative 1 is negative x. Change all the signs. Change my color as I change the signs. Change that sign there to a negativo, positivo right there. So those cross out. Those cross out. So that means we have a remainder of negative 2. But again, like I said, we don't care about that. All we care about is this. So our slanted asymptote is y equals x. And this just goes back to algebra 1. Even before that, just graphing a line, y equals x. Okay, so we will be doing that shortly. Since we did not cross out or eliminate any factors on the numerator and denominator, we're going to say that there are no holes. And we'll get to this part in just a moment. So let's go ahead and graph everything that we know, and then we'll go on from there. So we have a y-intercept of 2. So y-intercept of 2, I'll put a dot right there. We have x-intercepts at 2 and negative 1. At 2 and at negative 1. A vertical asymptote at 1. So vertical asymptote right here. And we also have a horizontal asymptote at y equals x. And so that means it has a y-intercept of 0, 0, up 1 over 1, up 1 over 1. So it's going to go along, I got to get this right here. So it's going to go along this guy right here. Just like that. It goes through all these guys just like that there. Okay, cool. So this one may be a little more apparent now because since we have points already on this side, see how it kind of is going to curve, you know, just like this kind of a thing. It's not going to cross over and then go down over here. It's just going to ride along this. But let's just verify that. And let's see, maybe we can plug in -2 or something like that. And actually, here, just give me a quick moment. Actually, did not prepare this one right here. I'll just quickly put this in my graphing utility for the sake of our time here. All right, so maybe if we did a few points, I'll just do them up here. So say if we plugged in -2 and -3. Okay, so if we plugged in -2, f of -2, we get -4/3. Okay, so -4/3 is 1, and then 1/3, so about like right there. Okay, so it's really close to that asymptote. And say if we did one more, -3, then you would get -5/2, or 2.5, right? So here, 1, 2.5, and as you can see here, it's just going to ride along this. So I'm going to go ahead and draw a nice curve right there, up and along it. And you could probably do a 50, 100 billion times better than mine on here. And then on this guy, like, you know, it's just going to follow this pattern right here where it's going to cut across. You know, you only need 5 points to get the full credits here. That's why it says at least 5 points. If you didn't see this, then you could have just plotted what happens at 3, what happens at 4, what happens at 5. So, but make sure that you should have at least on here 5 points. But of course, more the merrier to get your full credit right there. All right, so there's our second one.